Welcome to another Intermediate Algebra video. In this video, we'll continue looking at rational expressions. We've seen multiplying and dividing, and here we're going to look at adding and subtracting and everything that comes with adding and subtracting rational expressions. So our objectives ultimately are to add and subtract rational expressions, but something that we'll need in order to do that is to be able to do this first objective. Identify the least common denominator, or the LCD as I'll more commonly refer to it, of two or more rational expressions. So you've seen doing this with numbers before, and now we're going to do it with expressions. It's the same idea, but the expressions are involved, so it feels a little more complicated at times. Okay, our notes for this section. The steps to finding a least common denominator are to first factor each denominator completely. And the second step really is just then identifying what the least common denominator is. This list or this step here, it's kind of clunky, but every piece is necessary for it to make sense. So here's how you identify the least common denominator. It is the product of all unique factors, so multiply every different factor that you see, and they're each raised to the greatest power that appears in any of the denominators. So you'll identify all the different unique pieces and then raise them to the highest power that you see in any of the individual denominators. So those are our steps for finding an LCD. Then we have the steps for actually adding and subtracting. And you've seen this before with just numbers. So in order to add and subtract with fractions, you first need an LCD. You need a least common denominator. And technically any common denominator would work, but least common denominator is always the best. Then we will convert each fraction to have that denominator, to have that LCD. Once they're converted, then they're pieces of pizza cut into the same size slices, and so we can easily add or subtract, just kind of combine them together. And then our last step will be simplify, which is what we looked at in a previous video. Factor numerator and denominator, see if anything cancels out. This will be a step that is very easy to forget because you'll feel like you've done all the work, but it's an important one. Without the simplification, you don't have the final right answer. So first we're going to focus on finding an LCD. All right, so for us to find a least common denominator, first we need to completely factor each denominator. And I'm going to start with numbers because you've seen numbers before, and I want you to see the process roll over into polynomials. So there's nothing we can do to really factor 9 and 18, but we can break them down. And you don't always have to do this, but the idea will carry over into our polynomial denominators. So 9 can be written as 3 times 3, or more cleanly as 3 squared. And then 18 can be broken down to 2 and 9, and 9 to 3 and 3. So 18, 2 times 3, or in a cleaner way, 2 times 3 squared. So the first step is to factor, and this is pseudo-factoring. We just broke them down to their prime numbers. Then identify the least common denominator. It is the product of all unique factors. So looking at these lists, the unique factors that exist are 2 and 3, and each is raised to the highest power that exists in either denominator. So the 2 is only ever raised to the first power. The 3, the highest power we see, is a 2. So the least common denominator is 2 times 3 squared. And since it's all numbers, we can put them back together, and we know that that will multiply and give us 18. So the least common denominator for these two fractions is 18. The smallest number we could change both of their denominators to be able to have them cut into the same size pieces and do something with them. At this point, the question is only asking for the least common denominator. So watch for that. Not every problem asks you to add or subtract. Some are just about the practice of finding the least common denominator. Okay, so that's how it works with numbers. Let's carry that over to the rational expressions. All right, so our next problem, our directions again, find the LCD. We have 2 over 3x to the 5th y squared and 3z over 5xy cubed. So completely factor each denominator, and these are only one term, so there's not anything we can do to factor, but let's call this denominator 1, denominator 2. But we can kind of spread them out to get an idea of what the different pieces are. The first one has 3 times x to the 5th times y squared. The second denominator has 5 and x and y cubed. So that's as factored as we can get them. You could write y squared as y times y, but it's not going to be helpful here, so I wouldn't suggest it. You can, but you don't have to. Okay, then we identify the least common denominator. It is the product of all unique factors. We have 3, we have 5, we have x, and we have y, each raised to the highest power in either of the denominators, in any of the denominators. The numbers are both raised to the first power. The x, the highest we see is to the 5th, and the y, the highest we see is to the 3rd. Oh my gosh, not to the y. To the 3rd. There we go. So these are all the pieces. Now, if there were terms that had addition subtraction, you do not have to multiply those, but these are numbers, so we should pull them together. 3 times 5 is 15, x to the 5th, y to the 3rd, just kind of pulling everything back together. The only reason I've worked it out this way, we just took the denominator and kind of stretched it out, put a little space in between so we could more clearly see all of the different pieces of the denominator to identify each unique piece and then give the exponent that appears the most time. So this is an LCD. That's all we're focused on so far. All right, next one. Find the LCD of the two fractions 7 over z plus 1 and z over z minus 1. The first step is to factor each denominator. So again, I'm going to label them 1 and 2. Denominator 1, is there anything we can do to factor it? Z plus 1. There's no greatest common factor, and we can't use sum difference of cubes or sum difference of squares. So the factor z plus 1 is the only thing that exists. Okay, for our second denominator, we have z minus 1. There's no greatest common factor, and we can't use sum difference of cubes or difference of squares. So z minus 1 is the fully factored version of this denominator. All right. Our next thing is to actually identify the least common denominator. So this is where you look at all the unique factors that exist in each denominator. It's tempting to say, hey, well, they each have a z, so z, and then there's a plus 1 and a minus 1, so multiply all those things together. But these aren't being multiplied. They are, in and of themselves, their own factor. So you can think of them as having parentheses. Z plus 1, package deal. Z minus 1, package deal. They each are unique factors, so they each have to be in the least common denominator. So it's each unique factor raised to the highest power that exists in any one denominator. Neither of them have an exponent, so this is your least common denominator. You most definitely do not have to distribute. In fact, you shouldn't, because at the end it's possible you'd have to refactor, and you don't want to have to do it again. So this would be our least common denominator. All right, next. Oh, good, this is practice. Okay, go ahead, pause the video. You're only looking for a least common denominator here. Factor, find unique factors, raise them to their highest exponent. All right, let's take a look at these together. We're only focused on denominators when we're looking for a least common denominator. So our first denominator, I'll again separate them. We have x squared minus 4. This factors to x minus 2, x plus 2. The second denominator has a greatest common factor of 2, and when we take that out, we're left with x minus 2. The least common denominator, the product of all unique factors, all the unique factors that we see sitting here in these two lists. We have 2, we have x minus 2, and we have x plus 2. Each raised to the highest power that we see on any one individually. They all are only to the first power, so that's it. This is our least common denominator. 2 times the quantity, x minus 2 times the quantity, x plus 2. All right, so this will be step 1 when we actually add and subtract. And now we add and subtract. Again, let's start with numbers so we can draw the parallel to something that you've probably seen before. We have 2 ninths plus 1 18th. The first step is to find an LCD. We already identified a least common denominator for these two fractions. So I'm not going to go through that process again. You've seen that. The second step is to convert each fraction to have that LCD. So imagine this is where we're going. We have two fractions, we want them both to now have a denominator of 18. So then we decide, all right, what has to happen to this first fraction for it to be something over 18? It's 9. What needs to happen to turn it into 18? It needs to get multiplied by 2. So we do that to the top and bottom. 2 over 2 simplifies to what? 1, right? So we're multiplying by a form of 1. We're not changing anything. We're just taking the information we have and chopping it up into smaller pieces. Okay, so our new numerator is 4. In the second fraction, we already have the denominator of 18, so we're not doing anything to change this fraction. We're just bringing it down. So that's step 2. We found the LCD previously. We converted each fraction. Now we're on step 3. Actually add or subtract. Now that these are cut into the same size pieces, combine them together. They're being added. Their denominator stays the same, and we just pull the numerators together. 4 plus 1 is 5. And then the fourth step is to simplify. So however you need to simplify, simplify. 5 and 18 don't have anything in common, so that's as good as it gets. So this was a number problem to draw the parallel for you. All right, we're still starting slow. Our next problem, 5 over 7z squared plus x over 7z squared. We actually want to add or subtract here. So our first step is to find a least common denominator. Well, these two denominators are already the same, so there's nothing we need to do here. The second step would be convert them to have the common denominator, but they already have the same denominator. So the only thing we need to do with these is actually add them together. When you add fractions, the denominator remains the same, and you just work with the numerators. So what will this numerator be? It's very tempting to say 5x, but what's happening to these two fractions? They're being added together. So this will actually be 5 plus x. If those were like terms, combine them, but they're not like terms, so you can't. Okay, the last step is to then simplify. And remember, this means factor and look for things that are the same, different factors, top and bottom, to cancel out. Well, it's one term in the denominator, and there's nothing that these two have in common. There's no way to factor, so this is it. 5 plus x over 7z squared. All right, let's work our way up a little. Add, subtract. X squared over x plus 7 minus 49 over x plus 7. First step would be identify a least common denominator. Looking at these two denominators, x plus 7, they're already the same. So we don't need to find or convert to have a common denominator. They already have it. The next step, the third step, would be to actually add or subtract. So the denominator we have is x plus 7. The numerators, x squared minus 49. And the last step is to simplify. Remember, this means factor top and bottom. Look for the same factors and cancel them out. Our denominator we can't factor in any way, but our numerator can factor. It's difference of squares. This factors to x minus 7, x plus 7. And now we see if there's anything that will cancel out, anything that will divide out. We have an x plus 7, top and bottom. Those are gone, leaving us with an x minus 7. It's in the numerator. Sure, there's a 1 in the denominator, but we don't have to write that. X minus 7. It's only important if the x minus 7 was in the denominator. So all of that combined, subtracted to give you x minus 7. Okay, next problem. Exact same process. First, look for a common denominator. And we already have that. They already have the same denominator, 3y squared. The second step would be to convert them. We already have the same thing, so nothing to worry about. Now we actually pull these together. Okay, so they're being subtracted. We have x minus x plus 1, and it's very tempting to just write it like this, but it's the entire second numerator that's being subtracted. So you need parentheses around that whole numerator. Or you could distribute the negative right away to have a simplified line. You can do it here or you can do it here. It's up to you. That'll give us x minus 1 over 3y squared. Continue simplifying. X minus x is gone. We have negative 1 over 3y squared. And then check if there's any way you can simplify top and bottom. Well, they're each one term and they don't have anything in common, so this is it. Negative 1 over 3y squared. And it is different than if you had positive 1 over 3y squared. Owing money and having money, very different. All right. Next set of examples. Again, we're trying to add, so first, find a common denominator. Our denominators are x squared y and 3xy. Let's look at first, second. These are different, so we're going to have to find a common denominator. Our first denominator has x squared and y. Our second has 3 and x and y. So our LCD has each of those, 3, x, and y, to the highest power that exists. To the first, the x is squared and the y still to the first. So our LCD is 3x squared y. Okay, the next step is to actually convert each fraction. So we want each fraction to have this as the denominator. Now decide, all right, what is the first fraction missing? What needs to happen to this denominator for it to say 3x squared y? The only thing we're missing is a 3, so we multiply that in top and bottom, which gives us 6 in the numerator. In the second fraction, oh, look at that. Needs a squared there. In the second fraction, we have 3xy, we want 3x squared y. So what are we missing? You might say we're missing the squared, but be more specific. What does that squared mean? It means there are 2 x's. We only have 1. So what we're missing is 1x. So multiply that in top and bottom. 5 times x gives us 5x. All right, so we found an LCD. We converted them to have the common denominator. Now we actually add or subtract. In this case, add. We have the same denominator, 3x squared y, and in the numerator, don't forget it's addition, 6 plus 5x. And then our last step, check if you can simplify in any way. Can you factor the numerator? No. Can you factor the denominator? No. Do they have anything that you can cancel out that are factors? The answer is no. So this is as simple as it gets. There will be times the factoring is there. So it's always something to check. So to review, we first found an LCD. This was step 1. Then we converted. This was step 2. Each fraction to have that denominator. Then we added. And step 4 was not needed here. There was no simplifying to be done. So our final answer gets the stars. Okay, let's do another one. We have 5k over k squared minus 4 minus 2 over k squared plus k minus 2. First thing we need is a least common denominator. So I'm going to label these denominator 1 and 2. We need to factor each one. Our first denominator is difference of squares, which factors to k minus 2, k plus 2. Our second denominator, you can use AC, whatever factoring method you want. The purpose of this problem is not for me to show you AC again. The purpose is the actual addition. So I'm not going to show you how. You can go through the process of AC if you want to get here, but this one factors to k plus 2, k minus 1. All right, then our least common denominator. The product of all unique factors, each raised to the highest power that we see. So the unique factors we have are k minus 2, k plus 2, and k minus 1. And they're all raised to the first power. So our LCD sits right there. So I'm going to write these fractions with their factored denominators to start out with. So we found an LCD. Now we want to convert each fraction to have that LCD. So each fraction will have all 3. Okay, so we've set up the framework. We know what our LCD is. We just have to decide what's missing from each fraction. The first fraction has k minus 2 and k plus 2. It's missing the k minus 1. So that's what we're multiplying in, top and bottom. We already have it on the bottom, so on the top we have 5k times k minus 1. You can distribute right now or you can do it later. I'm going to try to be a little longer in my steps so you can see it all drawn out. Our second fraction has k plus 2 and k minus 1. It is missing the k minus 2. So our second numerator becomes 2 times the quantity k minus 2. I'm going to clean each of these up. Just the numerators. A lot of writing here. So I'm actually going to distribute the 5k and the 2 to their respective parentheses. So we get 5k squared minus 5k in the first numerator. In the second, 2k minus 4. Okay, now we're on step 3, actually subtract. So now these come together to have our one and only LCD, k minus 2, k plus 2, k minus 1. And now we pull the numerators together. So we have 5k squared minus 5k. Then the whole thing is subtracted. So I'm going to distribute the negative right away. This becomes minus 2k plus 4. There's our numerator. clean this up a little bit more. Ooh, let's box this off. So our denominator is still k minus 2, k plus 2, k minus 1. Our numerator, we can combine 5k squared minus 5k minus 2k is minus 7k plus 4. And then the last step would be to simplify this. So it would be possible for something to cancel with one of these factors if the numerator factored and included one. This one you can check via AC. 20. Nothing works there. You may have to go through the process on your own. When you're working these out, I know you can't look at them as quickly as I can to make that decision, but that's part of the process. The point in this section is not to linger on the how of factoring, but on the new process that we're learning of actually adding and subtracting. So this numerator does not factor, and nothing is the same with the denominator, so this is your final simplified answer. 5k squared minus 7k plus 4 all over k minus 2, k plus 2, k minus 1. This is the big culmination problem. If you can do this one, you can do basically any of the problems we've done throughout the entire video. Okay, so now let's move on to the practice problem. Here's your one and only practice problem to complete this video. Go ahead, pause the video, and then we'll go through it together in just a moment. All right, so remember the steps that we're going to follow. We're going to find, there we go, find the LCD, convert, add, subtract, maybe both, maybe just one. In this case, it looks like it's going to be both, and then simplify. So first, find the LCD. For our first denominator, there's no factoring to be done. The second denominator can be factored. This is the difference of squares. Maybe you remember x minus 1, x plus 1. And then our last denominator can't be factored. That's as clean as they all get. So our LCD has to consist of all factors that appear to the highest power that appears in any one denominator. So I definitely see a factor of x minus 1, and I see a factor of x plus 1, and that takes care of everything. There is not a repeat in any of these denominators. So there's our LCD. That's step 1. Step 2 will be to actually convert. Let's do this in blue. So the first fraction, what is it missing to have both pieces of the LCD in the denominator? It has x minus 1, so we multiply in x plus 1 on top and bottom, which causes the numerator to become 7 times the quantity x plus 1, so 7x plus 1. Okay, the second piece currently has x minus 1, x plus 1, and we want x minus 1 and x plus 1. So there's no change to be made there, so we just bring down that 10x. And the last piece has x plus 1. We want x minus 1 and x plus 1. So we need to multiply in an x minus 1 on the top and bottom. Remember, multiplying in the same thing top and bottom is the same as multiplying in a form of 1. So we're not changing anything. We're just sort of chopping it up into smaller pieces. And then we can distribute the 5 here, and we get 5x minus 5. Okay, the third step is to then actually add or subtract, in this case, all three things, the pieces together. So our denominator, they all have the same denominator, x minus 1, x plus 1. They have a common, so we can pull them together. They're all cut into the same size pieces, so they can get pulled together. And then our numerators, let's just do one line where we bring them all together. We have 7x plus 1 plus 10x, and then minus 5x minus 1. So that minus has to get distributed to each item in the numerator. So it becomes minus 5x plus 5. Okay, so they're pulled into one fraction. Let's keep this going by actually combining like terms. We have 7x plus 10x, 17 minus 5x gives us 12x. And then the numbers, we have 1 and 5, so we get plus 6, and this is still all over x minus 1, x plus 1. Good. Okay, and then the fourth step is to potentially simplify. So if we're going to simplify, we have to check if we have any common factors on the top and bottom. So let's go ahead and factor the top. They look like they have a 6 in common, so we'll take that out, giving us 2x plus 1. On the bottom, x minus 1 and x plus 1 stays the same. Doesn't look like anything cancels, so this must be the completion of our problem. And you could give this as your answer, the version where you factored, or you could present this one. If something did cancel out top and bottom, then it would be important to have gone through the process and leave the simplified line. In this case, since nothing canceled out, it would be all right if you left the previous line. If you've done the work, you can submit the factored answer. So we found the LCD. We converted each fraction to have that LCD. We added and subtracted the fractions together because now they were cut into the same size pieces. And then we simplified by looking for common factors on the top and bottom. I'll see you soon for another video.